Alright, today's video is about compound inequalities. Compound inequalities are two simple inequalities joined by and or. Example 1. Solving an and compound inequality. Solve and graph. So our directions are to do both things, solve and graph. Now notice how I have a variable in the middle and I have two inequality signs. Alright, it is important that one's less than and one's less than or equal to. We solve these inequalities like equations with one exception, which we will talk about in another example later. So I'm going to try to isolate t by itself in the middle. So I'm going to subtract 4, and just like equations, I need to keep this balanced, but I don't have two sides, I have three sort of sides, or three spots. So I need to subtract 4 from all three locations, left, middle, right. Okay, so negative 9 minus 4 is negative 13, which is less than t and less than or equal to 6. Alright, so now this is really solved, and we're going to graph it here in a second and talk about our solutions. So what this means is t falls between all of our solutions, negative 13 and 6. Or another way to say this is t is greater than negative 13 and t is less than or equal to 6. The not equal to bar here is important, and so is the equal to bar here. Negative 13 would not be a solution if I plugged it in for t, because this isn't equal to. However, 6 would be a solution because 6 is less than or equal to 6. So how does this graph? It's real simple to graph. Just graph it on a number line. Now we're not going to put all our numbers in, just 0, and then the numbers that are very important like negative 13, but relative to where they would exist on a number line. So negative 13 is to the left and 6 is somewhere to the right. Now, negative 13, because this doesn't have an equal to bar, is open, which is not included. 6, which has an equal to there, is going to be solid. And then all the solutions that make this true fall between here. So I shade in between. So there are infinite solutions here that fall between negative 13 and 6, not including negative 13, but including 6. So just shade that in. And this problem is complete. So if you were to pick any solution in the shaded region, like let's say we pick the number 1, plug 1 in for t. 1 is greater than negative 13 and 1 is less than or equal to 6, which is why it's shaded. It makes the statement true. Alright, let's move on to the OR type. Solving an OR compound inequality. Solve and graph. So 6x plus 9 is less than 3, or 3x minus 8 is greater than 13. There are two really separate problems here with an OR separating them. So we're going to solve them independently and write an OR between our answers. So let's do it. Subtract 9. Subtract 9. So 6x is less than 3 minus 9 is negative 6. If you have trouble with some of these negatives, go ahead and use your calculator. We're going to divide by 6. And so x is less than negative 1. Alright, that part is solved. So now let's solve this other part. We're going to add 8. Add 8. So 3x is greater than 21. And then divide by 3. So x is going to be greater than 7. Now, there's an OR here, so we definitely have to write OR with our answer. And this is our final answer down here. And we usually write OR all the way through. So this step should have an OR, and that step should have an OR. And so our final answer is x is less than negative 1, or x is greater than 7. Now, if you remember from simple inequalities, when you graph, if you have the variable on the left, the arrow in the inequality simply points to the way you're going to shade or graph. And so when we graph these, zero in the middle, Negative 1 is somewhere to the left of 0, and 7. You're not really graphing these super accurately, just relative to 0. Now, this is not equal to, so I'm going to have an open circle above it, and I'm going to shade to the left. Everything where x is less than -1, so that's this way. And then I darken in the arrow here too. And then x is greater than 7, so I shade here. Now that's an open dot also because that's not got an equal to bar. And I shade this way, the way the arrow points. Or you can simply think about it. All numbers over here are greater than 7. So now solutions here are infinite also, but it's an or statement. So anything less than -1 makes this true, or everything greater than 7 also makes it true. Now the other thing to emphasize here too is make sure you can tell whether your dots are open or closed. Like up here it's real obvious that's open, this one's closed, this one's open, this one maybe is not so good, so maybe I should fix it a little bit. Oh, it got rid of my whole entire line. So this came through here, but make sure you can tell that's open. Don't make it, so we have to guess. Alright, next problem. Example 3, solve and graph. Now right away I want to realize this is an and inequality. So we're going to solve it just like we did the first problem. So let's go ahead and subtract 1. Subtract 1. All 3 locations. So -3 is less than -2n is less than or equal to 6. Now here's where solving inequality differs than solving just equations. Here I have a negative, so I'm going to divide by a -2. Whenever you multiply or divide by a negative, you must flip the inequality symbols. In this case there are more than one, so you flip both. So this becomes 3/2. I go ahead and leave it as a fraction. You could turn it into a decimal, but it's a little easier as a fraction, I think. This flips this way. This is n. And this also flips the other way. And this is -3. Now, we're not going to leave it written like this. It's still a true statement, but generally we write these in a certain way, where the one on the left is going to be less than the one on the right. So I'm going to flip this around again, just a rewrite where -3 is less than or equal to n is less than 3/2. It just makes more sense to write it that way. So that is just a rewrite. Now let's go ahead and graph this. So graph it over here. And so 0. -3 is somewhere over here. 3/2 is anywhere over here is fine. And the dot for -3 is solid because of this equal to bar, and this one's open because there isn't an equal to bar. And we'll shade between the two because it's and. So you can see in some problems both of these are solid. They could be both open. One could be solid, the other could be open. And now remember back here, right here was the key difference to this inequality. So sometimes when you're watching a video, you need to write down something I don't write down. So I might, in this case, if I was watching this video, write down that when you multiply or divide by a negative, flip the inequality symbol. Right, now I'll pause for a second and allow you to write that down. So again, you should have written down somewhere in this problem when you multiply or divide by a negative to flip the inequality symbol. Very important. It's a very common thing to forget. Now example 4. I will solve this inequality, however I will make one error while solving. So make sure you pay attention. You need to write down the error I make, explain why it is an error, and solve the problem correctly for the next time we meet in class. So make sure you do that for the next time we meet. Alright, so let's watch how I solve this. Now I'll solve the other side. Alright, I'm done solving it. I have made one mistake in there. Now, I want you to follow these directions, again, read through them, and have that done for us the next time we meet in class. Alright, example 5. Milk will keep until its expiration date and will not freeze when stored at a minimum temperature of -1 Celsius and a maximum temperature of 5 Celsius. The temperature Celsius satisfies the inequality -1 is less than C is less than 5. Write the inequality in degrees Fahrenheit given the formula C equals 5/9 times parentheses Fahrenheit minus 32. Alright, now this is a little tricky at first, but if you notice, right here we have C. Whoops, I meant to hit the highlighter. Right here we have C, and we also have C here. So I can just do a direct substitution for C equals the expression. So -1. Because I don't want C there, I want Fahrenheit, which is what it says here. So -1 is less than, well, C is equal to 5/9 times Fahrenheit minus 32. Which is less than 5. Now, I'm going to have you finish this problem for the next time we meet in class also. So you have to work on number 4 and finish number 5. So solve this inequality and make sure you have it ready for us in class the next time we meet. Have a good day.